Hey everybody, so just to quickly summarize before we get started on today's notes, which is 10.3 day 2 notes, which is geometric series, the only thing we haven't gotten to. Really quickly, just to summarize what we know so far. Okay, so we have a few formulas here. We have writing a rule for an arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is the first term and d is the difference. Then to find the sum of an arithmetic series or sum of an arithmetic sequence, because you can still find the sum if you add up all of the numbers, is S sub n. So that's just, remember, notation equals n, which is the number of terms, times the quantity of, and then it's the first term plus the nth term, which is the last term, divided by 2. We also learned geometric series. This is for, sequence, geometric sequence. This is something that's differing by a ratio. A sub n equals the first term times that ratio raised to the n minus 1 power. So today we are going to talk about, well, how do you sum the terms of a geometric sequence? Okay, so which is called a series. So how do you find the sum? Okay, so the sum formula for a geometric series is the first term times 1 minus r to the nth divided by 1 minus r. Okay, so I could rewrite this down and put it here, but I'm not going to because that's just wasting time. Okay, so once again, if you're looking at what these are right here, this right here is your first term. And then R is your ratio. So what multiple is it differing by? Okay. All right. So consider the geometric series. So I don't have to check to see if it's arithmetic or geometric because it says it's geometric. So first thing I want to do is I want to read the questions that is being asked. Find the sum of the first 10 terms and then find n such that the sum is 31 over 4. Okay. So I want to find the number of terms in which when you add up all the terms, you get 31 over 4. That's what it's asking. Okay, so in order to find the sum, I'm going to need the first term, which I have, and I'm going to need the ratio, which is r. Okay, so I have the first term, that's 4, and now I need a ratio. So what do I do to a 4 to get it to be a 2? What do I multiply it by? Remember, if you don't know, you can just do 2 over 4, which is a half. So this is times 1/2. Now, if you said divided by 2, that's also correct, but we're looking for the ratio, so the multiple. Okay, and then this is continued here. That's also times 1/2. All right, so now I'm ready to use my sum formula. So sum of the first 10 terms is equal to the first term, which is 4, times 1 minus. Now, the reason that I have parentheses around this r is because if it's negative, you have to make sure you keep that r value negative and not say, ooh, it's minus a negative, that's plus. That's not true. So I just liked writing the parentheses in, but when it's positive, you don't need it. But this is a fraction, so you do. To the nth power, which is 10, divided by 1 minus 1/2. Okay. All right, so process that you're going to do here. So you could just type this in your calculator, but you're going to need a whole lot of parentheses. So what I like to do is I like to always do this mental math first. So 1 minus 1/2 is 1/2. So this becomes 1/2. And now I can put this in my calculator, okay? So I'm going to do 1 minus parentheses 1 divided by 2, close the parentheses, to the 10th power, and then I'm going to hit enter. Then I'm going to hit divided by 1/2 or 0.5 and hit enter again. Then hit times 4 and hit enter again. So if you do that correctly, you should get 7.992. And I rounded that to nearest thousandth. Now, if you're looking at this, these are fractions here. So obviously, if I keep adding fractions, I'm going to get a fraction or decimal answer. My calculator gives me decimal answers. If you wanted to change it into a fraction, remember what you can hit on your calculator is you can hit the math button. The first option is fraction. And if you hit enter, it will turn it into a fraction. So you can see that the sum of the first 10 terms is 1,023 over 128. It doesn't tell you how I want your answer, so either one's fine. So most people will just stick with decimal. All right, so this one says, find the number of terms in which the sum is 31 over 4. So I gave you the sum is 31 over 4. And I don't know, or I do know the first term, it's 4. All right, it's just still from this, it's still 4. Times 1 minus, I do know the ratio, it's still 1/2. To the nth power, which I don't know why that turned into a circle. The nth power over 1 minus 1/2. Okay, so now I need to solve for n. N is right here as an exponent. Remember, I use logarithms to solve for exponents, so you can always use logarithms to end up solving this once you get the 1/2 to the nth power by itself. But it might be one that you know. So like if it was like 2 to what power gives you 4, you don't have to use logarithms, right? So keep that in mind. Okay, but if you don't know, you can always use logarithms. Okay, so to simplify this, I'm going to simplify it similarly to how I simplified the last one. So I'm going to start by simplifying 1 minus 1/2 because I can do that mental math, and that's 1/2. All right, the next thing that I always do to get this moving here is realize that, once again, this is one big fraction right here. All of this, since it's multiplication, is in the numerator. So what I'm going to do is I'm going to simplify this by doing 4 divided by 1/2. Okay, so that I can get rid of my denominator. So now I have 31 over 4 equals, and then 4 divided by 1/2 is 8. So I have 8 times 1 minus 1/2 to the nth power. I can keep that 1/2 in parentheses still. Okay. All right, so now I need to get rid of the 8. So to get rid of the 8, I would divide by 8, but since I'm working with fractions right here, remember another way of getting rid of an 8 instead of dividing by 8 is you can multiply by the reciprocal. So what I'm going to do is I'm going to multiply by 1/8. That way I can keep this a fraction and not turn it into a decimal. Remember, when you're multiplying fractions, you multiply straight across. 1 times 31 is 31. 8 times 4 is 32. So now I have 31 over 32 equals 8 divided by 8 is 1. That's why it cancels. And now I have 1 minus 1/2 to the nth power. All right, now I need to get rid of that 1, so I'm going to subtract 1 from both sides. All right, so now I have 31 over 32 minus 1. My answer is negative. So now I'm going to do 1 minus 31 over 32, which is 1 over 32, equals negative, and then 1/2 to the nth power. Now I can get rid of this negative right here by dividing both sides by -1. It becomes a positive 1 over 32 equals 1 over 2 to the nth power. All right, so now, yes, you can use logarithms if you're like, I don't know, but I like to just think about it and sometimes use my calculator for guess and check. So I'm thinking of a number that I can bring this to get 1 over 32. So like let's show you what I mean by guess and check. If I plug in 2 here, square the 1, that's 1, got that. But square the 2, that's 4, that's not it. So it's not 2. All right, so if I do 3, I'll get a 1 in the numerator. I'll get an 8 in the denominator. That's not going to work. So 2 to what power gives me 32, basically, is what I'm asking myself. And that is the 5th power. So n is 5. So the sum of the first 5 terms is 31 over 34. Okay, so this next one is basically an exact replica of, no, it's not, because then it would look exactly the same. It's just the same problem with the numbers changed, right? The same type of problem. So if you want to pause the video and try it yourself, that'd be great. When you get to this step, though, when you get to this part right here, there's an easier way of doing it, or there's something different that happens. So if you get stuck there, feel free to fast forward to that part in the video if you got everything else right. Okay, so I want to find the sum. To find the sum, I need the first term, which is 2, and then I need the ratio. So what do I multiply by to get my each next term? So r is -2. Okay. So the sum of the first 16 terms is equal to, and then I'm using my formula once again, which is the first term, which is 2, times 1 minus r, which is the ratio, which is -2, very important with the parentheses here, to the nth power, over 1 minus -2. And notice I put it in parentheses there also, because I would have double negative, which I can automatically change to plus. But let's talk about that right now. Oh, and I put an n right here, and I do it every single time I teach it. We know what n is. It's 16. Okay. All right. So things that you can and can't do. So what people want to do is they want to say, oh, this is plus. Okay. But it's not, because this says minus negative 2 to the 16th power. So negative 2 is raised to the 16th power. You have to do the exponent first and then do 1 minus that, right? Yeah. So it's important that you know that. On the denominator here, there's no power here other than 1, so like I don't have to worry about it. So this you can distribute the negative into. The top numerator you can't, the denominator you can. So this is the same thing as plus. Okay, so now I'm going to clean this up so I can put in my calculator. I'm going to do 1 plus 2 by myself, which is a 3. And now I'm going to put this in my calculator. 1 minus parentheses, negative 2, close the parentheses, to the 16th power, enter. Divided by 3, enter. Times 2, enter. And you get the sum of the first 16 terms is negative 43,690. Okay, so you might say, I have this, but I just got the wrong answer in my calculator, so make sure you're listening to how you type it in your calculator. All right, this one I want to find n, so I'm solving for n, which is my exponent, when the sum is 86. So 86 equals my first term, which was 2, 1 minus my ratio, which was negative 2, to the nth power, this is what I don't know this time, over 1 minus a negative 2. All right, so once again, I'm solving this. Once again, I cannot, in the numerator, distribute this negative here. I can't do that because it's in parentheses and raised to a power. This, however, is not raised to a power. It's raised to a first power, which is okay. So this I can actually change to a plus sign. All right, so now I'm going to change that to a 3. Okay, so now remember the next step that you did was you said, okay, this is one big fraction right here. I'm now going to do 2 divided by 3. And the last one, it was 4 divided by 1/2, which is, ooh, it's nice. But 2 divided by 3, I get a decimal. So I'm just going to leave it as 2/3. So I'm going to do 86 equals 2/3 times 1 minus negative 2 to the nth power. All right, now I need to get rid of that 2/3. So I'm going to get rid of that 2/3 by multiplying by the reciprocal. I'm going to multiply by 3, which will cancel out those 3's. And I'm going to divide it by 2, which is going to cancel out those 2. So I'm going to multiply this by 3 and then divide it by 2. All right, so I'm going to do 3 times 86 divided by 2 in my calculator, and I get 129 is equal to, and then I have 1 minus negative 2 to the nth power. Okay, now I'm at the point where I can get rid of these parentheses. Oopsies, these parentheses here, I don't need them. They're not helping me in any way because I'm trying to solve for n right there. Okay, so I'm going to subtract 1 from both sides. I got 128 is equal to negative 2 to the nth power. I need to get rid of this negative here, so I'm going to divide both sides by negative 1. And now it's negative 128 is equal to negative 2 to the nth power. All right, so now once again, I can use logs, or I can think through this, use guess and check, whatever I like. Okay, so I'm looking for a number that I bring to, I have negative 2, and what number do I bring it to get negative 128? So first thing I know before I start checking is that my answer is going to be an odd number, because if it's even, it would never give me a negative answer. So I can start by, I know it's not 5, because we just said 2 to the 5th is 32. I can skip 6, so I'm going to try 7. Negative 2 to the 7th power is negative 128, so the answer is 7. Okay, so next two here, find the sum of each series. They're just written differently, but they mean the exact same thing. So I could plug in, we know how to do these problems where I can plug in 1, I can plug in 2, I can plug in 3, all the way up to 10, and then add them all up. But it's just a lot of work, right? So if this was a 2 up here, then I'd probably plug in 1 and plug in 2, okay? But since there's multiples there, since there's 10 things I have to plug in, The first thing I say is, okay, so this is a sum. Now, is this a sum formula that's arithmetic, geometric, or neither? Okay, so remember, arithmetic looks like a line. So arithmetic looks like a line, like 3n plus 7, right? So if this was 3n plus 7, it'd be arithmetic, right? So something like that if it's linear, which this is not. Geometric looks like an exponential function, right? So 3 to the nth power, or 2 times 3 to the n minus 1 power. If there is an exponent that is a variable, that is a exponential function, and therefore it's geometric. So if you look here, this is geometric. If you look at the next one, this is geometric. Therefore, I can use my geometric sum formula, okay? Tomorrow, not tomorrow, but the next set of notes, which is a review, I will have them all mixed up and we'll make sure that, like, you know, like, can I use a formula? If so, what formula would I use? Okay, so in order to use the geometric sum formula, you need the first term. So my first term, okay, so what I'm going to do is I'm going to plug in 1 for n and see what I get, because it says right here your first term is by plugging in 1. So I get n 1 minus 1, which is 0. What is 6 to the 0 power? 1. What's 1 times 1/2? 1/2. Now, here's the little shortcut to that. This is written in the form a sub 1 times r to the n minus 1 power, right? That's our formula. That's our formula for geometric, right? So I could have just said, oh, that's the first term. Now, that only works if it is to the n minus 1 power right here, right? If it's n plus 2 or n minus 6 or just n, then this is not your first term necessarily. Okay. Let's go back to this. Let's erase everything I just wrote over this. Okay, so quick way, my first term is 1/2, my ratio is 6, and now I can use my sum formula. So I want the sum of the first, and then I see how many terms. I need to plug in 1 through 10, so that's the sum of the first 10 terms. All right, so now I'm going to use my formula. It's a sub 1, which is 1/2, times 1 minus my ratio, which is 6, to the nth power, which we just said is 10, divided by 1 minus 6. All right, I'm going to clean this up first. I'm going to do the denominator, which 1 minus 6 is -5. And then now I'm going to put this in my calculator. In my calculator, I'm doing 1 minus 6 to the 10th power, enter. Divided by -5, enter. Times 1/2 or times 0.5, enter. And I get the sum of the first 10 terms is, big number here, 6,046,617.5. So we got a pretty big number here, and it's because this is an exponential function, right? Your numbers are getting exponentially bigger. So that's why that's happening. All right, this one right here, I need my first term. I need my ratio. Okay, now I can see my ratio is 1/2 without a problem, but 7 is not my first term necessarily, due to the fact that this is not n minus 1. Okay, so I have to check to see what the first term is. So I'm going to look here, and I'm going to say, what am I plugging in first? 0. N to the 0 power, 0. 1/2 to the 0 power, 1. 7 times 1, 7. So it happens to be this time. Great. If this was a 1 right here, no, it wouldn't be. Okay? All right, so now using your formula, go ahead and pause the video and try it yourself and see if you can get the same answer as me. Sum of the first. So this might be something that you messed up right now. If this was 1 through 11, it'd be the sum of the first 11 terms. But it's 0 through 11. So if you count how many numbers there are when you count from 0 to 11, that is 12 terms. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is 12 numbers. So I need my first term, which is 7, times 1 minus my ratio, which is 1/2 to the 12th power, divided by 1 minus 1/2. 1 minus 1/2 is 1/2, and then go ahead and put that in your calculator. 1 minus 1/2 to the 12th power, enter, divided by 0.5, enter, times 7, enter. And I get the sum of the first 12 terms is 13.997. Okay? Okay, so what we just learned was sum of a geometric series, right? Now we learned sum of a geometric series where they gave us the last term, like 10th term. What's the sum of the first 16 terms? What's the sum of the first 11 terms? 10 terms, 12 terms, whatever. But what if I ask for the sum of an infinite series? So this formula just doesn't just come out of anywhere. Here's an explanation of where the formula comes from. So here's your sum formula, right? If I make the number of terms infinite, okay, so if I put an infinity right here, if I put in my calculator 1 minus 2, let's say, okay, to the second power, and I see what that is, and then do the third power, and I go like, okay, let's try the 10th power. Let's try the 100th. Let's try the 1000th, and I keep putting in numbers there. What you're going to end up seeing is that simplifies to, that gets closer and closer to 1 as you're getting closer and closer to infinity. It's a limit idea. So this is a sub 1 times, this becomes 1 minus 1 of the 1 minus r. And then just to make it cleaned up, if you put this over 1 right here and multiply these two, that's where you get this a sub 1 over 1 minus r. So this you're only using if your ratio is less than 1, okay? And that is the absolute value. So if r is in between 1 and negative 1, and it's an infinite series, you're using this formula. If r is greater than 1, so if your ratio is 2 or 3 halves or 7, anything bigger than 1 or negative 17, anything less than negative 1, then if you think about it, if I keep multiplying something by 2 and adding it up forever, the sum of that series is infinity, right? So if your r value is greater than 1, the sum of an infinite series is infinite. Okay, but if your ratio is a fraction basically, or a decimal that's in between negative 1 and 1, then you use this formula. Okay, find the sum of each geometric series. So it's infinite. So I'm going to use my infinite formula unless the ratio is greater than 1. If the ratio is greater than 1, the answer is automatically infinity. All right, so let's ask ourselves, is this arithmetic, geometric, or neither? It's geometric, right? Because I have nth power here. All right, so I need to know my first term, which is negative 5. And I need to know my ratio, which is 1/2. Okay, so 1/2 is in between negative 1 and 1. So I am using my infinite formula right here. So the sum of this infinite series is equal to a sub 1, which is negative 5, over 1 minus r, which is 1/2. So this is like super easy. Like it's not difficult to work with. 1 minus 1/2 we know is a half. And then negative 5 divided by a half is negative 10. Here, I want to find the sum of this infinite series. Now it's infinite, it goes on forever and ever and ever. So first off, I need to know the first term, which is 90. And I need to know the ratio. So this would be a third of that, right? A negative 1/3. Or I can look at it as negative 30 over 90, which simplifies to negative 1/3. So r is negative 1/3, which is in between negative 1 and 1. So I can use my sum formula for an infinite series. So the sum of the infinite series is equal to your first term, which is 90, divided by 1 minus negative 1/3. No exponent here, so I can distribute that negative. So 1 plus 1/3 is 4/3. And then I'm doing 90 divided by 4/3. If you're using your calculator and you're typing this, make sure you're doing 4/3 like this. Okay, because if you don't, it's going to divide it by 4 and multiply it by 3. We want to divide it by 4/3. Okay. All right, so you get the sum of that infinite series is 67.5. All right, last but not least, this one right here. So first off, let's see. It says they're all geometric, so that's why I haven't checked the last two. All right, so what do I multiply a fourth by to get a half? What do I multiply a half by to get 1? What do I multiply 1 by to get 2? These are all times 2. All right, so times 2 times 2 times 2. So my first term is a quarter, and then my ratio is 2. Now, 2 is not in between -1 and 1. It is greater than 1. So if I keep doing this, realize the next term is going to be 4, and then 8, and then 16, and then it's going to get bigger and bigger and bigger and bigger. So if I ask you those numbers and add them all up, it's infinity, right? You can't, it's just not doable in a, now I'm babbling because my Schoology closed out here. It's just not, it's not possible to get that sum, right? So I shouldn't say it's not possible, it's just that it goes on forever and ever. Okay, the rest of this is review. So if you're like, got it, I would go ahead and pause the video, but I don't necessarily think that's a good idea right now because you'll kind of see me folding back in the other stuff and how you know what formula to use. So try to stick with me here for a couple more minutes. This is a sum, right? So I have to ask myself, do I use the arithmetic formula for sum, the geometric formula for sum, or am I plugging in 1 through 250? Okay, my computer keeps freezing, not my computer, or maybe my Apple Pen's done, so let me plug that in hopes that it works. Okay, so, or am I plugging in 1 through 250? That's not the answer, I'll tell you that much. That's way too much work. So you're going to look right here, and you're going to say, is that arithmetic or geometric? Is -3n plus 5 arithmetic or geometric? What is going on here? Oh my goodness. Oh my goodness. Okay, so this is linear, so this is arithmetic, right? So you're going to use your arithmetic sum formula, which I listed at the top of your paper right here. It's the number of terms times the first term plus the nth term divided by 2. So the number of terms, so the sum of the first 250 terms is the number of terms, which is 250 times the first term. So I need to plug in 1 here. -3 times 1 plus 5 is 2. Plus, I need my 250th term, so I'm going to plug in 250 here. -3 times 250 is -750, plus 5 is -745. And then divide that by 2. So I'm putting this in my calculator. I'll put this first, then hit divided by 2, then hit times 250, and you get the sum of the first 250 terms is -92,875. All right, let's look at this next one here. So it's sum. So I say, do I use geometric, arithmetic, or neither? Okay, so I look at it and I say, is this arithmetic? No, because this is not a line. Is this geometric? No, because this is not an exponential function. Okay, if it was 2 to the nth plus 1, that's an exponential function. Okay, but n squared, that's a quadratic. So I cannot use a formula. I have no other choice than plugging in 2 through 4, which is not a big deal. So I'm going to plug in 2, 3, and 4, and then add those up manually. All right, so plugging in 2. 2 squared is 4. 4 plus 1 is 5. Plug in 3. 9 plus 1 is 10. Plug in 4. You get 17. Add those up. Your answer is 32. Could you do that here? Yes, but you would have to plug in 1 through 250. All right, last one, find the 400th term of this sequence. So I want to find a sub 400. In order to do that, I need a rule. In order to write a rule, I need to decide if it's arithmetic or geometric. So let's look to see if it's arithmetic first. What do I do in a -7 to get it to be a 1? Or sorry, -1. Add 6, add 6, add 6. So it's arithmetic. To write an arithmetic rule, I need 2 things. I need the first term, which is -7, and I need the difference, which is 6. Now I can write my rule. A sub n is equal to my first term, which is -7, plus n minus 1 times 6. And now I'm going to distribute to get my rule, and so it looks like a line. So that's 6n minus 6. And then a sub n is equal to 6n minus 13. So that's the rule. Now I can find the 400th term. 6 times 400 minus 13. I get the 400th term is 2387. Okay, so hopefully that wasn't too fast for you. I tried to speed talk, but that is our notes. If you need to rewind and look at anything, feel free to do so, but go ahead and get